So for problem number 3, we have, with the acceleration shown in the figure below, an object starts from rest at an origin. Calculate the speed of the object if it traveled a distance of 1,000 feet and the time needed for the object to travel that distance. So this is how the graph looks like for problem number 3. So the first thing that we have to find is the velocity. So we have a given acceleration here. So this is what we are going to use. So for So at 0 to 1,000, this point, this 1,000, when acceleration, ito yung acceleration natin. So the formula that we are going to use is the integral of ADS equal to V. So ito S 0 to V, since we don't have a given position and velocity. So the next thing that we're going to do is we are just going to substitute the value of acceleration. So the integral of limited to acceleration, which is 75 minus 0.025 s, okay, ds is equal to the integral of v dv, which is limited to 0 and v there. So the next thing that we are going to do is we are just going to integrate. So we have, for the first term, we have 75s minus 0.025. The integral of 0.025s is s squared over 2. That is for the first term. And then we have v squared over 2. So to cancel these values, we are just going to simply multiply it by 2. So cancel 75 multiplied by 2, we have 150s multiplied by 2, cancel si 2, so maiiwan is 0.025 s squared is equal to v squared. So kailangan is v lang ang matira. So paano ba natin ma-eliminate or ma-omit yung exponent niya? So we are just going to square this term. So v is equal to, para natin tanggalin yung squared. So square root of 150s minus 0.025s squared. So ito na yung value natin ng velocity. So ang given na situation natin is given din yung position. So pwede na natin i-substitute yung 1,000 dito sa ating mga variables. So v is equal to the square root of 150 multiplied by 1,000 minus 0.025 multiplied by 1,000 squared. So calculating this will give us square root of 150 times 1,000 minus 0.025 times 1,000 squared is equal to 353.55 feet per second. So this is our velocity. So that is it for problem number 3.